Hello, my name is Carla Richter, and today I want to talk about my master's thesis, in which I've built an experimental setup for measuring a device-independent proof for the indefinite causal order inside a quantum switch. So let's start with a brief introduction of what is indefinite causal order. And for this, I want you to imagine a two-party scenario with a quantum state. In this state, we can send, for example, first to party 1 and then to party 2. And each party can measure and re-prepare the state, or we could do this the other way around. In both cases, we would end up with a temporal order that we do not have any problems to understand or to describe. However, in quantum mechanics, we are allowed to describe processes that are in superposition of these two orders. And when this happens, we cannot simply speak about a mixture of probability 1 and probability 2. Instead, what we have is a causal inseparable process. And one example of such an indefinite causal order process is a quantum switch. For the quantum switch, we need two qubits, a control qubit and a target qubit. The target qubit is the one that experiences the measurements inside the switch, and the control qubit is the one that decides about the orders of these operations. So if the control qubit is in superposition, we kind of transfer this superposition onto the order inside the switch. And what makes the quantum switch especially interesting is that we can create it experimentally in the laboratory. This has already done several times, and the experiments gave us strong results that give us good hope that what we have there actually represents an experimental indefinite causal order. However, as long as we rely on assumptions about the quantum state or the process that happens inside the quantum switch, we cannot fully exclude that our results could somehow be explained in a different way. So what we need now is a device-independent proof, very similar to what we have with Bell inequalities for entanglement. Unfortunately, up to recently, there has not been a device-independent test for the quantum switch, and now in 2023, van der Lugt et al. Have come up with a new protocol that they call local causal inequality, and this can be especially broken with the quantum switch. And it relies on 4 parties. 2 of them, LS1 and LS2, are positioned inside the quantum switch, and one, which is called Charlie, is space-like separated from the quantum switch, and a 4th party, Bob, is space-like separated from all others. And each of these parties have a set of measurements and settings, and only if the process inside the switch is a indefinite causal order, the classical bound of 7/4 can be broken. So from this, we now want to test if we can break this local causal inequality. So the goal of my master's thesis was to build a setup that is capable of doing the measurements for breaking the local causal inequality. And it contained of several measurement stages. Here in orange, you see what we would call Bob. So we had a single photon source that created a 2-photon Bell state, and one state would be sent immediately to the measurement stage of Bob. And the second one would be sent into an interferometer-like setting where we would transfer the polarization degree of freedom into a time degree of freedom for creating time bins, which we use as a control qubit inside the quantum switch. And the polarization degree of freedom of the photon is what we use as a target qubit for the measurements inside the switch. And then we have the measurement stages of Charlie that we have split up onto 2 tomography stages that allow us to measure the target qubit and the control qubit at the same time. So the second part was to test the quality of the setup, because the measurements for the inequality are quite sensitive. And I did this with an experiment that allows to distinguish between commuting and anti-commuting operators with only a single use of each operator, which is only possible with a quantum switch. And from the results, we got the idea that we actually are good enough to break the inequality in the final measurements. And even so, it was not part of my master's thesis anymore. I continued with the experiment, and I'm happy to announce that actually with my recent measurements, I managed to break the causal inequality. And so that's it. Thank you very much for listening.